All right, so the first one, if you have a piecewise function, in order for you to tell, you know that you change patterns or what you're doing. So you have one line, and then you're going to go to a different line. In order for it, there's two things that can happen when you have a piecewise function. One is that it could go like, you could have one pattern that does, I don't know what it could do. It could do something like this, and then you have maybe an open circle and a closed circle, and like where you have this jump. Or I also could have like, it does something like this, and this could be an open circle, a closed circle, and then I can have an open circle, and it does something like this, where they happen to meet at the same piece. This one is discontinuous, this one is continuous. Does that make sense?
Yes.
So this is a line, this is a line, and this is a line. So I know a line is usually continuous. So I'm not worried about that. The only place I'm worried about is at this 1/2, whether they meet at the same place or not. Does that make sense? So what I have to do is I have to put 1/2 into both of them. So 2 times 1/2 minus 1. So that'd be 1 minus 1, and I get 0. Good? And then I have negative 2 times 1/2 plus 3. So this is negative 1 plus 3. So this would be 1. Since these are not the same number, not the same, then what happens? Is it continuous or discontinuous? It's discontinuous. Now, is it removable or non-removable? Non-removable. It's non-removable because the only thing that happens on a piecewise function is you either have this case or this case. So this one is going to cause like a jump, and if it causes a jump, it's non-removable. You don't have to say jump, but you did have to say discontinuous. You did have to say non-removable. Good? Didn't ask where, so I don't have to put the 1/2, but if you put the 1/2, that's perfectly fine. The next one, if I go to do this one, it's a rational function. This is just like we did before. I look at my denominator. When this is equal to 0 is when I'm going to have a problem. So this ends up being 3x is equal to 9, x is equal to 3. So I know it's discontinuous at x is equal to 3. Is it removable or non-removable? Right? Non-removable. Why? Because it doesn't simplify. It cannot factor out. And so those are the answers. Is everyone good? If it were something like this, where I had like x plus 3, x minus 2, and then I had this x plus 3 in the denominator, and those could factor out, it'd still be discontinuous at x is equal to negative 3, but it would be removable. Good? Understand the difference? Yes.
What would that graph look like?
That would actually look like a straight line, but you're going to have a hole that you won't see until, like if you graph on your calculator, you're not going to see until you go to tape. Okay? Everyone good? Any questions on the worksheet? Going once. Going twice. Fine. Okay. So we stopped with continuity. We stopped with whether something was continuous or not continuous. We did not start the limit, the one-side limit yet, did we? So up until this point, we've taken the limit. So you're back on your note sheets. We took the limit as we just approached the number. So in order for us to have a limit, we said it had to approach the same number from both sides. What we're going to start today is what's called one-sided limits. And it's kind of like confusing. We're going to have directions. So I'm going to have this little plus sign, and I'm going to have this little minus sign. The plus sign means that I want to know what happens to that function as I approach from the right. And this one is going to be as I approach from the left. If I approach two different numbers, then my limit's not going to exist, but it's possible for me to have a one-sided limit and not an overall limit. Does that make sense? It'll make sense in about 10 minutes, maybe 5. So this one's approaching from the right, so I look as the x is approaching from the right. The other one's approaching from the left. So if I have the limit, when I'm approaching this number, I'm looking at what happens as I'm approaching from the right. So I'm technically moving to the left, but I'm approaching from the right. As I'm approaching from the left will be the negative sign. So let's just do one. I think it's so much easier. So I have this guy, limit as x approaches 2, and then this that's really poorly typed, but this is from, that's with the 2, so it's a limit as x approaches 2 from the left, a 5x minus 2. Now, if I look at this, if I remember what I just did last night, I know that it's discontinuous at 2, right? I know that it's non-removable, and from what we studied back with rational expressions, I know that since it's non-removable, what happens at 2? No, if it were removable, it'd be a hole, but since it's non-removable, it forms a vertical asymptote. So what I'm going to have to do is I'm going to have to graph this. So get out your calculators and graph this whole thing. Because it doesn't simplify. So like, if I go back to this guy here, this would be a hole because it simplifies. Yes, ma'am?
Why did you say
Vertical asymptote. Oh, I don't know why I put the asymptote. Vertical asymptote. Silly. So I'm hoping. Did you graph it? Are you guys done graphing? What? Nick, did you graph? Did you graph?
No. I'm graphing.
The formula, but it is incorrect.
No, it's not.
Oh.
That's why I rewrote it down here.
You get rid of the negative sign.
This negative sign is saying when I go, because I approach the
Oh,
vertical
it's
asymptote
two.
with 2. This negative sign, oh, poor color choice. I don't know what I'm
Oh,
doing.
okay, that's what it is.
This is saying from the left, yes?
Yeah, now let's do it.
So that's, oh my, I'm just a mess right now. I'll be good. Just give me a minute. Here we go. I am recording. It's going to be a mess. Poor Jack. Sorry, Jack. So sorry. This is from the left. There's 2 Jacks. So there's my vertical asymptote that my calculator's not going to draw, yes? So as I'm approaching from the left, I'm coming, this is the left, right? This is the right. I said left, right, that was really bad. So I should have said this is the left, correct? I'm approaching from the left. As I approach from the left, I'm approaching the left, approaching the left. What does this graph appear to do?
go down?
It appears to be going down, which doesn't really seem like it's going to stop, which, what did we say? Negative infinity. So I'm going to say that this whole limit is approaching negative infinity. Now, just to be clear, when I say that, I'm saying that the limit does not exist. It's not approaching one number, but I can do these one-sided limits. So I can say, as I approach x, as I approach 2 from the left, the graph will go to negative infinity. Does that make sense? Yes, sir?
Why are you doing it only from the left?
Because you told me to only do it from the left.
Okay. What would
And
it be like for the right?
Well, great question. So if I do x as approach 2 from the right, so then I'm going to have that little plus sign from the right. This will be 5x over x minus 2. So as I'm approaching from the right, I'm coming this way, and what does that graph appear to be doing? Positive infinity. Pardon me? I'm traveling to the left, but I'm approaching from the right. Yes. Yes. I don't know. Moving on. Do you guys have this one?
Yeah.
All right. This one is approaching from what side?
The right.
Right. So this one says that you're approaching from the right. So you should have a graph that looks like this. as I approach from the right, what does it appear to be?
Zero. Yeah, close to zero.
Approaches 0. And I believe, if I'm not mistaken, that this is one of the ones that you could have actually done direct substitution and gotten an answer, right?
That's good.
But just to be clear, if I asked you to take the limit as x approaches 4 from the left of this, I know I can substitute in 4 and get 0, but am I approaching 0 from the left?
No.
No, so this one still does not exist.
Wait,
Because there's no graph to the left, so I cannot approach from the left. So the limit does not exist.
and the first one is
No, the first one is 0. It does exist. I can go like this, approaching with 0. Okay, the next one. And so the limit of f of x is x approaches c. Notice there's no plus or minus on that c. The limit of f of x as x approaches c is equal to limit if and only if the limit from the right and the limit from the left are equal to the same number. If they are not equal to the same number, then the limit does not exist. So, like, I want to go back. I'm going to go way back here to this guy right here. So see this one that we did earlier today?
yes.
So if I gave you this function and I asked you to do the limits of f of x as x approached 1/2 from the left, that means when x is less than 1/2, right? We would do this formula here, and that's when we did the 2 times 1/2 minus 1, and we got 0. That would be 0. You with me? If I would do the limit as x approaches 1/2 from the right of the same function, I'm putting 1/2 in here from the right means when it's greater than 1/2. So negative 2 times 1/2 plus 3, and I got 1. So the limit from as I approach from the left is 0. The limit as I approach from the right is 1. Everyone good? But if I asked you the limit of this function as x approaches 1/2 without a direction, you would tell me what? Does not exist. And your reasoning would be because it does not approach the same number. Does that make sense?
Yeah.
Okay. And here's another thing too. If they both, say I have a graph that does this, and let's say this is this, and I have a graph that does this and this, and let's say this is 3, and I take the limit of f of x as x approaches 3 from the left, you would tell me that's what? Positive infinity. If I asked you for the limit of f of x as x approaches 3 from the right, you would tell me positive infinity again. If I asked you for the limit of f of x as x approaches 3 without a direction, you would tell me what? Does not exist because it is not approaching one single number. Make sense? Even though I have infinity, positive infinity on both sides, the limit does not exist. Say that again.
Why do you say positive one side and the other side?
Because when I put this direction on it, I'm technically taking away the idea of finding a limit. I would just want to see like the behavior as I approach. Does that make sense? So it's like I'm doing a different thing. All right. So everyone knows what this means. What does this mean? Does anyone know what the double bracket means? No, that's the greatest integer. You guys know how to find that on your calculator? It's the INT on your calculator. I think you can type in INT. So what I want you to do is I just want you to graph this. So graph that, the greatest integer. Everyone has a calculator?
Can you just use the brackets?
I think you can be in that function and just type in INT. I think. Huh? Do you have 2 brackets somewhere? Where are those 2 brackets? Oh, does that work? Does it give you this graph? Does it give you a stair step?
No.
No.
It's do int parentheses what you want.
Yeah.
I can type int.
I am saying,
Alright. Any number with int here?
X. You're graphing.
Int.
Are you graphing?
Yeah. Oh, that is
Oh,
no.
my. Alright, so this is a graph. Everyone good with the graph, yes? Then the next thing it asks you is if I want to find the limits as x approaches 0 from the right. It's,
Oh.
well, I'm doing what it says here. So this one says approaching from the right. So here I'm approaching from the right. So when I go to that graph, here's 0. I'm approaching from the right. So what number is that going to be? If I'm approaching from the right, 0. And then this one, if I'm approaching 0 from the left, as I'm approaching 0, here's 0, now I'm approaching from the left, so that's going to be -1. If you weren't sure, you could do that menu trace, graph trace, and you could set up a table like we did before. Jack?
Why do you choose the middle ones? Like, yellow.
Because I'm approaching 0.
Oh, okay.
So now, this is asking me, now if I ask you for the limit, as x approaches 0, no direction side, as the greatest integer of x, you would tell me that does not exist. Good? So this one's talking about continuity on a closed interval. So sometimes we like to look at just a small fraction of part of our graph and we want to talk about whether it's continuous or not. In order for it to be continuous, these endpoints have to be defined on that interval to be a closed interval. So if I'm talking about, it says discuss the continuity of f of x. So I have this graph here that I drew. This is the equation that I got from it. What is my closed interval where I can find a value?
-2 if you have some A.
So I can go -2 to 2. And I'm putting brackets because if I took the limit of f of x as x approaches -2 from the right, it would be 0. And if I took the limit of f, should I write this? I should put the limit of f of x as x approaches -2 from the right is 0, which equals, and that's equal to f of -2, yes? And then the limit of f of x as x approaches 2 from the left.
Are you still doing -2 or positive?
Oh, no, this is positive 2. Oh, this is positive 2 because now I'm approaching here from the left. And that's going to equal 0, which is going to equal f of positive 2. Make sense? Yeah. That is the closed interval. And by closed, that means I have brackets on either side. It's a closed interval which the function is continuous. There is nowhere else where that function is continuous. There's nowhere else that the function exists. Does that make sense? It only exists from -2 to +2. I'm sure I did. Any questions? Just leave it. Okay, so let's suppose I'm driving at night and I'm pulling out my driveway. At 9 o'clock at night. My car, before I start driving, is at 0 miles per hour. Yes? I'm driving a Nissan. I don't know.
No, it's always gonna be when you're.
At 9:24, at 9:24, I pull out of my driveway, get on the freeway, and now I'm going 55 miles per hour.
Why are you going so slow?
Huh?
Why are you going so slow on the highway?
Anyways,
Yeah,
I think you were speeding at a 45.
okay, but I would not take a picture while I was speeding.
So, it's your bad.
So, my whole point is here, did I ever drive at a rate of 20 miles per hour?
Yes.
Yeah, I had to. Does that make sense? Did I ever drive, can I say that I ever drove at a rate of like 34 miles per hour?
Yes.
Yes. Can I say that I ever drove at a rate of 5 miles per hour?
Yes.
Did I ever drive at a rate of 60 miles per hour? Maybe, I don't know. But I know that if I'm driving consistently from 9 o'clock to 9:24, that car has to hit every number between 0 and 55. Does that make sense? The only time I can say that is if it's a continuous function. If it wasn't a continuous function, then I could not make that assumption. Does that make sense? Like I couldn't have a jump in my graph. Like, you know, some of those piecewise functions, I could have a whole period where it wasn't, I never hit any of those speeds, but a car doesn't work like that. A car, you start and you continuously drive until you reach the top speed, yes? Okay. So that is an example of what's called the intermediate value theorem, and we use the intermediate value theorem a whole lot, but most of the time we use it to find our zeros. What it's saying is that if you're in a closed interval from A to B, so A to B, then I can make the assumption that I hit every, and it's continuous from A to B, that I hit every value between f of A and f of B. That's what the intermediate value theorem says. Does that make sense? So like if I put numbers in here, if I wanted to put numbers in here and I made this 1 and I made this 3, so if I was continuous from 1 to 3, and let's say this is 10 and this is 40, then I'm going to hit every value between 10 and 40. Does that make sense? Most times we use this is if I know that, like, if I hit a positive number and I hit a negative number and I'm continuous, what do I know I have to cross somewhere in between?
0.
0. I have to cross 0 somewhere between a positive and a negative. Does that make sense? Or if I go the other way, if I'm negative and then I'm positive and I'm the continuous function, then somewhere in between there I had to have a 0. I had to hit 0. Make sense? You cannot say you can say and I can say that I can say that I hit like 35 somewhere in here, but I can't say where I hit 35. Does that make sense? Like I can say that I'm between positive and negative, I can say that I hit 0, but it doesn't tell me where I hit 0. It just tells me that somewhere between those two numbers I hit 0. Good? Makes sense? So if I have this function, and I give you this function, and I say that in the interval from 0 to 5, does there an f of 10 exist? The first thing I have to do is decide, is it a continuous function? So is sine a continuous function?
Yes.
Is cosine a continuous function? Is there ever a place that you can remember from trig where the sine did not exist? The sine was undefined. You remember graphing sine? You do remember graphing sine. So sine was a curve that went like this and kept on repeating. And cosine was a curve that went like this and kept on repeating. Yes? Continuous, continuous. Is x plus 3 continuous? Is if I divide by 2, is that continuous? So I can say that the whole thing is continuous. Yes? So I am going to have to find f of 0. How am I going to find f of 0? Plug in 0. Am I going to do this the thinking man's way or the hard way? We're going to do the calculator. Well, because I don't know the sine of 3. You know the sine of 3?
It's 3 radians apiece.
No, 'cause that's 3.41 radians.
A little less.
What? We do. We only have one more section. So what does this equal? 20 times the sine of 3 times the cosine of 0. Well, the cosine of 0 is 1, I know that. Huh? Say that again?
2.8224002.
Alright, so then. And now I'm going to find f of 5. Why do I keep on putting parentheses in? Yes? 286?
Oh wait, I don't know why.
Why? It's not that I don't believe you guys, but well, cosine 0, is it? What'd you get? 0 squared. This is for the last one. I just did that one. I'm checking your results. Huh? I'm trying. Sine, that's 8, right? Times the cosine. And you can't stop me. I'm doing it. I'm making it 25. Are you good with that? 25? Over 2? Mm. So if I'm at 2.8 and 19.7, can I assume that the graph hits negative 10? No. Why not? Yeah. Okay, so if I ask does, does it, yes. So sorry. So I can assume that it crosses 10, but I cannot assume that it crosses negative 10. Good? Easy? That is easy, right? Okay, use the intermediate value theorem to show that the polynomial function has a 0 in indicated value. So this is what I'm talking about. In order to say that it has a 0, what do I have to cross between? What kind of number, what kind of number? Positive, negative, or negative, positive, right? So, polynomial function, is it continuous?
Yes.
That's the very first thing you have to make sure. Is it continuous? If you're not sure it's continuous, I guess I could graph it and check the table in that period, yes? So I'm going to find, I don't have to do a calculator for f of 0. What is f of 0? Negative 2, right? And then, because these x's are gone, huh? That's why I intercept. So if I put in 0, it wipes out those x's. I'm only left with that negative 2.
So if you're left 0,
Oh, because it's a polynomial function. The only time it wouldn't be continuous is if I was dividing by something. A trig function possibly would be discontinuous. A piecewise function, square root. Then you can't do it. You can't use it. The intervening value can does not work if it's discontinuous in that interval. Not possible because it's not continuous. Like if the denominator is equal to 0. That was the beginning of. So this is 1, 4, 2, yes? So can I say, show that it has a 0, I'm going from a negative to positive, it has to cross 0, yes? This one, do I have a 0? So I'm going to find f of 0. So 0 squared minus 2 minus cosine of 0. Well, the cosine of 0 is 1, so that's going to be negative 3, I think. Somebody better check my math. And then f of pi, oh, I like pi. Oh, I have no idea what pi squared is. No idea.
8.87.
Well, I could, this is negative 1, right? So I'm going to end up with pi squared minus 3. Yeah? So yeah, I guess I agree with whoever said, because this has to be 9 point something, so this will be positive. But tell me what it is. 8.869. Okay. So I'm going from a negative to positive, so I have to cross the 0. Not hard. Not hard. Okay. So you guys did the 1 through 8 already, so you're finishing it. We're actually going to finish that now. I'm going to throw people up at the board to finish that. Then this is what's due on. Yeah, you had it last week. I feel no guilt. That's what's due on Thursday.
Like 30.
Okay. So I'm going to throw some people up now to do some of those problems. Okay, so number 10, I'm approaching 3 from the left. When I look at this function, I'm going to say that it's discontinuous at x is equal to 3. It does not simplify, so it's non-removable. Since it's non-removable, that means I cannot do direct substitution. I cannot put that 3 in and just get an answer like I did for number 9. So what I'm going to have to do is I'm going to have to graph that. So I'm going to pick up my calculator and I'm going to graph that. If I'm having a good day. Maybe not, maybe not. And so I'm going to do negative 1 over x minus 3. I don't know why I did that. I get that graph. So I'm just going to do, so this graph is something like this. When I hit 3, it went, what am I doing? Something like that. I don't know. It should be 0. It should be 0. Okay, there we go. Much better. As I'm approaching 3 from the left, so I'm approaching 3 from the left, so I'm going this direction from the left. What is that going to be? So I'm going to write positive infinity. Good?